Hello everyone, welcome to the next episode on Anubhav Learning Series. In today's episode, we will talk about how to analyze performance of SAP OData Services. We will look at both the options to analyze the performance. Both of them are producing ultimately the same result, but it's just about looking at the perspective in which you would like to obtain the performance statistics. One from the perspective of a Fiori developer who has no clue where is the SAP backend server, and maybe you don't even have access to the SAP backend server in cases. Option number two is for directly the backend developers who are working day and night with OData service development, and they would like to analyze performance at times for their OData services. So these parameters which we will explain today's session are extremely important for you to understand overall what's going on in the system. Before we start, let's have a quick look at architecture once again for an SAP gateway-enabled OData services. So there are two possible architecture for Fiori applications which are enabled by the OData services. One is central hub scenario, and another is embedded deployment. So in the central hub scenario, we have basically two application servers in the application layer. The first one is called Fiori front-end server. Yeah. Fiori front-end server, or you also call it as SAP NetWeaver Gateway. And then you have another component called SAP Backend or Fiori Backend Server. Yeah, that's where your functionality is residing. So in companies these days, what we observe, majority of them are not going with central hub scenario, rather they are going with embedded deployment where both of these components are installed in a single physical machine. But at times we have observed that many of you are working on the central hub scenario where the gateway system is separate than the backend system, and they all connect via something called an RFC. So we will consider that for our example to understand what happens to the performance when this kind of scenario happens. So of course, if in your company somebody would ask you which is the better deployment option, again it depends. The central hub scenario is costly, and also it can cause confusion to the developers, major confusions like where do we deploy our Fiori app, where shall we build functionality for OData, where should we expose the OData from which server shall we create destination in WebID for. So these confusions may come. So in our anubhavtrainings.com's online training for UI5 and Fiori, we will explain you about all these doubts and questions and the best practices you should follow in your case of implementations when it comes to UI5, Fiori, Gateway, and ODatas. So, but today's session is not about that. Today's session is to understand the performance statistics. So assuming that you already have fair idea on OData services and SAP Gateway and Fiori, then this session will be helpful. If you don't, if you're new to it, we would strongly recommend you to subscribe our UI5 and Fiori training from anubhavtrainings.com. So now let's go ahead. So now this is the scenario, central hub scenario, where your gateway OData service is registered over here. So your service registration is done on the front-end server, and your service logic, the application logic, resides in the backend server. Yeah, this is basically your DPC class implementation. All right, that is the setup we have it currently. Now, when you call an OData service now from an external agent like a browser, for example, in this case, we will be using directly the browser to call this service. What happens is the call goes and the response comes back. So it's a request response architecture based on the RESTful architecture. So now what will happen, the call goes, it does the processing, it makes a call via the RFC to the backend system, the application logic executes based on the resources which are available in the backend server, and the result will be sent back to the front end. Here is where the parsing and parsing of the data happens, and also all the processing to construct the response will be taken place. For example, user requested data in JSON. So all that construction happens, and then finally the response will be sent back to the caller in form of a response based on the request type whether it was JSON or XML or maybe sometimes XLSX, right? So then there are, you can see different layers involved. So of course, each layer is going to consume some time. And how do we measure which layer is taking how much of time? Sometimes your OData performance is not good, and that reflects clearly, apparently, on a Fiori application, and then the users are complaining that Fiori app is slow. Then Fiori developer basically says, I have nothing to do. I'm getting response very slow from the backend OData service itself. So I cannot help much. So then the ticket comes to your name, and you as a backend developer probably have to find out where exactly the pitfalls are. Is it in the application logic? Is it in the service layer? Is it in the middle between the RFCs taking too much of time? Are the system resources are occupied correctly? In terms of work processes, you all know that SAP has the concept of dispatcher and work processes. So in your backend server, you have different varieties of work processes who are currently working, and some of them are waiting state, and some of them are in the state of working. So it depends on the load on the system. Suppose you are running at the parallelly in the backend system hundreds of background jobs which are consuming a lot of processing power, which are occupying these work processes. Of course, the work processes are not free, and when an OData request is coming here, there is no work process to serve this particular OData request. And then in that case, the system has to wait until the work processes, one of the work process is ready to take up your work. So all these things are actually combiningly matters to the performance of your OData service. So how can we now check all these different aspects when it comes to OData? So let's imagine you are just a UI developer. You want to yourself check it. Yes, of course you can do it. Or you are a backend service developer. You want to probably do it on the backend. Both options are available. So we'll go from the perspective of browser first of all. So let me just open one of the OData service, so-called Gateway Sample Basic Service. Is available in all the NetWeaver systems. You can just simply activate and test it and just experience basics of OData as we have done it in our sessions in the UI5 training. You all are well aware of this service by far. So now what I did is I just hit the business partner entity set and just gave me some data in the JSON format. That's not what our purpose. Our purpose is to now analyze and understand the time consumption at each of the layers. So I will switch to the development tools F12, and now I will refresh again, and we just go to the network calls and observe what's going on here. So you can see it has made a call to the business partner entity set. And when it's making this call, it has got some response header, and I have no clue. I have no way to find out how much time this request has taken in each of the layer. How much time this request has taken on the gateway layer, how much time it has taken in the middle, basically the RFC call, how much time it waited for work processes to become free so that I can acquire them and start my processing by my application logic, and how much is the actual time taken on the application logic side, how much was the backend time to process my request itself, and what was the overall latency in the whole process. So that's what I want to check. So now I will switch back again. So you see right now we have no clue, no idea what's happening. So what you can easily do, and it's very easy and straightforward, you just have to go in the browser window and put a parameter called ampersand SAP hyphen statistics equals to true. The moment you feed this parameter to your OData service, this means something to the system. And now the system will actually start kind of a trace at runtime, and it captures this important information in terms of time consumed in each of the layer, right? So that's something which you're never willing to put when you're using the service in the app, but rather you would like to do it just like, for a short period of time and just keep it and then check the performance. And now watch out, I press enter. Same call, there is literally nothing changed in terms of data, in terms of my call, in terms of, but just added this SAP hyphen statistics equals to 2. And now when you come down, wow, you can see in the response header, we've got, wow, beautiful. We've got so many parameters over here, which explains a lot about the time consumption in each of the layer. So we'll go through them, some of them, the important ones, one by one. Now, one thing you need to remember that all of this time is in milliseconds. All right, this is all in the unit of this time, which has come out for each of the layer is in milliseconds. So now what I'm going to do is I will step by step explain you each of the parameter and what does it mean. Some of these parameters are just the total. So now this is the list of values. Don't worry, I will also share this PPT with all of you. You can just find the description of this YouTube video to navigate to the PPT, and then you can also download and explain it to anybody when the time comes. So the first parameter comes is GWHub. This is the time or the time spent by the system into the hub system in the gateway framework. So when you make a request, the gateway has to receive the request. It has to now understand the request, what type of request it is a get, put, post, and then it has to redirect your call to the particular method, whether it is get entity set, create entity. So it has to do that all processing to redirect it to the correct method on the backend. So that is the time for redirection, which is it has taken on the hub system. So basically this particular time, if you look at into the picture, the GWHub time is the total time in the milliseconds taken in the hub system. So I would say I will mark it here. Yeah, so this is the time it is taking. The next parameter which comes is the GWRFCOH, and as you can clearly see, RFC remote function call. So when you have a gateway hub or hub-based deployment in your company, there is some transition time to send this request to the backend, and that's what the RFC time is. So if you go back and try to map it in the picture here, you will see this is the time it takes in the network between the gateway layer and the backend layer. This is the time. So of course, in a embedded system where there are no separate gateway, there is no separate backend, it's all at one single system. This time will ideally be zero. And that's where, the latency, that's why we say embedded system performance is much better as compared to the gateway hub, because there is no RFC latency over here. So now if you go back and check here in our response, because ours is a gateway system, which is embedded one. So you can see this GWRFCOH is zero in case of our server, which we are currently using over here. Yeah. So now I'm going to come back. So then also you can check here the gateway framework time. It's 61 millisecond. That's okay. That's basically anyway it has to take to redirect it to the correct get entity set, get entity, post entity, and all those methods. So that's a gateway time. But RFC time is zero because there is no different systems. They are not connected by RFC. It's a local system which has everything. Both gateway and the backend components are installed in a single physical machine. So I hope these two parameters are clear. Let's move to the next one. Next one comes is gateway backend. Yeah, this is the time spent by the system in the backend server to basically receive the request and process it. So now here it's this one over here. So in the backend system, it has to now assign a work process. So it is taking some time to acquire a work process and then start processing. And then finally, your application logic. This is the real actual time which you're spending in the execution of your business logic, GW app time. So GW app time is your actual business logic execution time, which is being used here. So this is the time your actual application is using. Sometimes people say your application, which is there, you've written a bad code. Your OData is good, but there's a problem in your logic. So that you can easily find out now. If GW app time is too high, there is definitely some room of improvement in terms of performance in your application logic. But in case, on the other hand, if this time is too high, or this time is too high, or this time is too high, then you can accordingly redirect to the basis team to look at the performance of parameters of the system. Are there enough number of work processes available to handle large number of requests? Are they having a good memory in the system? Is there any kind of leaks happening or not? That's something which your basis guys has to check. If there's a problem, this time is too high, then probably you have to rethink and look at your RFC connection accordingly, and then see if that there's too much of congestion in this RFC connection between these two systems. So that's another time which you can, of course, observe. So now the next parameter, let's look at the next one. This one is non-GW time and this app sometime. Okay, these are two very interesting parameters. Let's start with non-GW time. What is non-GW time? Sometimes you request data in JSON format. Okay, you say I want JSON data. Sometimes you say I want XML data. So now the system has to construct this JSON, and then gateway system has to take some time to construct this JSON actually. So that's this time. Now I will just show you a quick example here. I will go back and you can see here this non-GW time. You can see this non-GW time is currently 0 because I'm getting the JSON response which is cached. But now if I take the same call and I will go back and just press another F12 and open another window over here. I'll just do that, and now I just put here again the call, and in here instead of JSON we'll just put XLSX. Okay, I want now data in Excel format, and you can see system is downloading in Excel, but now important is to just look at this the statistics here. And if you come down, you can see GW non-gateway time is 196 milliseconds. It has added up 196 milliseconds. So earlier it was 0. But now since we have used the format as Excel SX, the system has to now construct that Excel sheet. And that's an extra processing which it is taking to add up this GW non-GW time. So basically it's not a time for taking your request and giving your response, but it's an extra processing which you instructed to do, hence this time gets added up. So that's this parameter, and then comes these two parameters which are only relevant when you do batch operations with parallelization on. What does it mean? So now coming back to the concept of Fiori, let's imagine there's a Fiori app running on the browser. So what Fiori does, as you all know, I've shown it in one of the chapter. I will also put the link out here in the description of the video, that all the Fiori calls which are sent to the backend are sent in form of $batch. So basically, if you have a Fiori logic, what you are doing in, let's say, in a JavaScript method, a Fiori method, you have, let's say, save. Now in this save, what you're doing, maybe you are calling a get request on one entity set, then another get request, and then you're making a post request, and then you're making a delete request, and then you are ending your save method of your Fiori. Now, what exactly Fiori does? It is not going to make multiple calls to the backend. Rather, it's going to combine all these calls, get, post, and update in a $batch. It will make a packet of these calls. And that makes, of course, very much sense, because you don't want to hit the backend again and again from Fiori app. You don't want to make multiple recursive calls. Rather, you want to packet everything in one single batch call and send it to the backend. And when it reaches to the backend, you can see all of these calls can actually be processed in parallel. So this get call, first get call, second get call, and then you have a post call, and this the update call. They all are processed in parallel actually by the system. Depends again on the work process availability. Of course, it's subjected to that, but they are all entitled to process in parallel. Now, let's say the first get call is taking about, let's say, 5 millisecond, and the second one is taking 10 millisecond, and the third one is taking some time. So let me just note down here, this one is taking 10, yeah, and second one is taking 5. So just put it here, the second call, they are all processed in parallel. So second is taking 5, the third one is taking, let's say, 20, and the last one is taking maybe, let's say, 15. But actually they're all processed in parallel. So when the response will be sent? Response will be sent based on the maximum time which is taken. So maximum time was taken by third call. This post call took the maximum time. Rest all got processed. System will park the response of these three which got processed before the last one. And once the last one is complete, it will combine the result and it will send the response back to the output, back to the Fiori app. This is how it works. So this way, you see, you are not spending time as 10 plus 5 plus 20 plus 15 to process the entire batch. Rather, you're just spending max time of the individual request, which is 20. So within 20 seconds, parallelly everything got processed, and this is the default behavior of the system, how system behaves by default. So let's now understand what that does that parameter says. It says that only in case of patch parallelization, fine, some of the service implementation in multiple operations. So basically this parameter will be a sum of all the calls, just an additional information. So of course the actual time taken was 20 only to process this whole batch, but the parameter will actually tell you 10 plus 5 plus 15 plus 20, how much that comes, 30, 40, 50. It will show you 50 milliseconds as a total time, but actual time which was taken to process was 20. So you can just also observe that how much was the total if in case your parallelization was switch off. Okay, so basically this parameter will help you to know what about if I switch off the parallelization, then it's going to be processing them one by one, not on parallel. In that case it is going to take 50 milliseconds to process everything, the entire batch. So since thanks to parallelization, since it's on, the total time which it will take is the max time of individual request. That much will be the total time. The next one comes is GWBE wait time. Now, let's imagine there is a parallel processing which has started. Now, the first one, second one, third one, fourth one, they all started parallelly. But now, the moment you start your application, let's say, imagine there are only 3 work processes are available. So the first one was fed to the first work process, second one was given to second work process, and third one was given to third work process. But now there are no more work process available at this point to process the fourth request in parallel. In that case, the system has to wait until one of them gets completed and the work process is free, so that dispatcher can assign this last work to one of the free work process. So in that case, system is waiting for work process to finish. So this is very, very helpful. At times, let's say you're firing hundreds of OData calls and you think that it will work seamlessly without any problem, but system doesn't have enough work processes to handle. Then in that case, the system will be keep waiting and keep queuing your request in the dispatcher until the next work process is free. And only then ultimately your batch response will come back to you. This happens in complex applications where there are too many calls. You're just flooding the application with so many calls of OData. You must just be thinking, okay, SAP system is so powerful, it will handle. No, depends on work processes available. So system is waiting. So gateway framework is waiting until the next work process is available, and that wait time contributes a lot. So be careful when you're firing thousands of requests to the backend. You need to be very, very meticulous about it. You need to first ask your basis guy how many work processes do they have to handle the OData requests. Basically, it's I think managed by dialog work process only. So you have to just check the dialog work process count if it's enough, and only then you need to start. Otherwise, this time will be too high. And you can also find that out by the parameter when it comes back. Since we not made a batch call here, you will see currently these values will come as wait time will come as 0 and all, right? So you see this gateway backend and those wait time will. So right now it's not even showing those parameters because I'm not making a batch call. Okay, so it's not even showing that. So that's the time. Then there are last 2 parameters. One is FW and GW total. So FW is just a convenience parameter, which is just a total of hub plus backend plus RFC. So what was the total time taken by the system to process your request and prepare your response, to make a call to the backend, do the processing, and come back. So that's a system time actually. This is something which is, if it is too high, you can open a ticket to the basis team, in simple words, right? Because this is something related to system. You don't have any control on it. Depends on the system performance. And now the GW total is actually a sum of GW app time plus FW time. So basically it's the complete time, entire time taken by the system to process your whole request, including the application time. So if the app time is too high, then you need to look at your application. There's something wrong, something really wrong in the application code, your above code, which is taking too much of time. So these parameters are very helpful to give you some insight where exactly your app is taking too much of time. Let's just quickly check FW over here in the browser. So if you come back, FW is 61, which is essentially a total of GW total. Sorry, let me just check here. The parameter is FW is GWHub Backend and RFC. So you can see here GWHub Backend and RFC. So you can just check. Hub is 51, backend is 10. So 51 plus 10, it's coming 61. You can see it's coming as total 61. Cool. And the next one comes is GW total. So you can just see GW total, which will be a total of FW 61 plus app time. 61 plus 14 comes 75. So these are all the convenience parameter. Other than that, now we also have the ICF parameter, the Internet Communication Framework, how much time that has taken, the ICM total, the ICM extension, and IC extension. So how much framework and extension time was taken by ICF framework, that also is coming over here. So this way it is very, very handy and helpful for you to process the gateway time. So this is about the as a UI developer or as a consumer, you can analyze quickly and also project this to the developers and the basis team to tell them that, hey boss, there's something wrong here. This is where it's taking the maximum time, and you can continuously observe it 2-3 times with consecutive calls, and then maybe do some kind of analysis and project this data back to the developers to give some insight to them about where potentially something is taking too much of time. On the other hand, if you are just a backend developer, you are the developer of the service, you can also use another transaction code here in the SAP system. It's called /n/iwfnd/traces. And this is where you can go and activate a performance trace. And now you can just make your call. So now the system is going to start the trace. So let me just go back. And you don't need now this parameter, basically just making a call to backend. Backend is now tracing all the calls which are coming, and it's also going to capture the statistics of the performance of each of the calls. So all the data which you just saw on the browser, you will now be able to see the same data on the backend actually. So now we've got this performance. So let's go to performance traces. And yes, you can see just there was a call which has come on the business partner, and you can see the processing time, application time, gateway time, request size. You can also go to the details, and you can also drill down and see at what level, which of the, what are all the calls which were actually made by the system. So I think I can double click. Yeah, so you can see here what are all the calls which are made. So maybe just try some other entity set to show you better. So maybe just try product set, press enter, and just go back and check this. Since some of the responses are cached, performance is little higher. Now just make a different call. So let's come back and refresh again. Just refresh here. So you'll see now the next call, and it's complete statistics, how the gateway has called your application layer and what methods were called. The complete trace you can actually see it, which is very handy and helpful for you as a backend developer to analyze the performance of the OData calls. So if you go inside, you see this one took relatively higher time because there was no response cached. Gateway hub time, you see gateway backend time, application time 71 milliseconds. So you see almost everything is under control. So non-gateway time 1 second, 1 millisecond to prepare the JSON response. So if I just simply make another call with XLSX, you will see that non-gateway time will increase to a little more. So I'm just, because now it has to process and the data and prepare in Excel. So you see Excel got downloaded for products. And now this is actually more processing involved here to prepare this Excel by the system. And as a result of that, system will take more time. So I'm just going to go back and show you and just refresh over here. And you will see, yes, you see 327, it has increased because of Excel processing. And when you drill down, you will clearly see that the known, okay, you can even see here, it took more time for non-gateway time. Milliseconds is 196, from just 1 second to 196 milliseconds got added up to prepare an Excel format for the data. So you can see your application took less time relatively this time, but the processing time on the gateway has increased because it has to also process the response of the Excel to the consumer. So very handy information, and you can also replay here the same requests and then see the performance traces like this. You can do a lot of stuff in this transaction code. Maybe you can just explore more options out there. This is how you can check the performance statistics, the detailed statistics of each of the calls which were made, which are all the methods which were called. All of these you can always check it out. So I hope this session was very helpful for you. If you like this session, please feel free to subscribe this channel and hit the like button on the video. Do let me know what next topic you want me to create more videos on in the comment box below. Always watching my videos regularly and appreciating. Thank you so much to all of the viewers on this channel, and I hope to see you in the next video. Thank you so much, and goodbye from Anubhav.